Bismillah, alhamdulillah, wassalatu wassalamu ala rasulillah. These are the last three exercises I'm going to present in this section. And I think by reaching this stage now, you can solve each of these exercises by yourself. So please try to solve this exercise by yourself first, and then look to the answer. As usual, we will use the ratio test. We are writing an plus 1 divided by an or multiplied by the reciprocal of an. Then we look for cancellations. And then we write what is left, making sure that if the number is positive, we can take it out of the absolute value, like this number, and like 8. But x plus 6 could be positive or negative, so we have to keep the absolute value. And then we take the limit when n goes to infinity, and the limit of this quantity when n goes to infinity is 1, because you take the highest power over the highest power. Then this will go to absolute value of x plus 6 over 8. And then by ratio test, series would be absolutely convergent if x absolute value of x plus 6 over 8 is less than 1, or if absolute value of x plus 6 is less than 8. And this gives us the radius of convergence and the interval of convergence when we add -6. So x is between -14 and 2. But one thing we have to do, we have to test at the endpoints, test the series at the endpoints. So we have to go to the original series, the power series, and replace x by -14. So -14 plus 6, -8. And you always notice if everything is going good with you, then you always hear there is a cancellation. Okay, this quantity has to be something related to what is below. Okay, there is some cancellation. So I will have, this is 8 to the power n, this is -8 to the power n. If you divide, you get -8 over 8 all to the power n, or -1 to the power n times square root of n. And this series is in fact divergent by test for divergence, because you immediately notice that the limit of square root of n when n goes to infinity is infinity. So when we have -1 to the power n, the limit will be does not exist. The other value is 2. When I replace x by 2, 2 plus 6, 8 to the power n will be cancelled with 8 to the power n. And I will just have this series, which is divergent by test for divergence, because the limit of an, which is square root of n here, is infinity. So the interval of convergence consists of this interval from -14 to 2, and you can check everything is fine. Putting the center here, the center is -6, x plus 6, so you put it equals to 0, you find the center, which is -6. You look to the endpoints, and what is the distance from 2 to -6? 2 minus -6 is 8. So the distance here is 8. 8 is the radius of convergence, so everything is good. Well, I have NN. Okay, so I can use the root test here. And when I take the nth root of this, let me write it. Absolute value of x minus 2 over n all to the power n. So n goes with n, and I'll have absolute value of x minus 2 over absolute value of n, which is n because n is positive. And when n is infinity, anything over infinity would be 0. So by root test now. By root test, series is absolutely convergent for all values of x, because we always get 0, less than 1. So the radius of convergence is infinity, and the interval of convergence is from -infinity to infinity. I have n factorial, so I'll use the ratio test, n plus 1 factorial to x minus 1 to the power n plus 1. Here I have n plus 1 when you cancel these two, and I have absolute value of 2x minus 1 to the power 1 inside the absolute value. Well, the limit when n goes to infinity would be infinity. So this goes to infinity, which means that the series by the ratio test series is divergent, except at 2x minus 1 equals 0 or x equals half. When x equals half, I'll have 0 here. 0 to the power n is 0, and it would be series of 0 summation 0, so it will converge to 0. So when x is half, the series is convergent. So the interval of convergence here is the number half, and the radius of convergence is 0 because it is half the center and we did not move anything, not to the right, not to the left. So this video is important because we studied 3 different examples in which these are the 3 possible cases. Whenever you have a power series, either you have an interval, the interval of convergence is an interval, or real numbers from -infinity to infinity, or just the center of the power series. I hope you enjoyed studying power series. Have a nice time.